Hi everyone, and welcome to today's webinar, the Insecurity of Node.js Applications, hosted by Ilja van Sprundel, who's our Director of Penetration Testing for IOActive. Before we get started, I just want to let you know that throughout the webinar, everyone will be on mute. However, at the end of Ilja's presentation, we will hold the Q&A session, where I will read out the questions that you have submitted, and Ilja can answer these for you. Alternatively, if you don't want to ask any questions on this open forum, please feel free to email your questions to us at info@ioactive.com. Now, without further ado, let me hand over the mic to Ilja. Ilja, over to you.
Hi. I'm assuming everybody can see my screen. If not, Craig will hopefully let me know.
I can see it, yes.
So yeah, I'm talking about, what's that?
Just saying we can see your screen.
Oh, perfect. Okay. And it's full screen slides, right?
Correct, yes.
I'm going to assume that's the
Yes.
Okay. So yes, this talk will be about node.js application security or insecurity. Yeah. So who am I? As Craig always said, I work at IOActive. I'm the Director of Penetration Testing Code. I read code, I test code, I break code, break stuff for fun and profit. So what's on the agenda today? It's basically sort of I'll first talk about, what node.js is, which is, I'm assuming you already know, and then I'll sort of speak as to what the audience is that I'm expecting. And I'll go into, why node.js, entry points, and then I'll sort of talk about 3 classes of bugs I've seen in node.js applications. And then I go into detail in all 3 of these classes. And then, I have somewhat of a conclusion. And then we'll open it up to a Q&A if anybody has questions. So what does this talk about? It's not about bugs in node.js itself. We're assuming the runtime is okay. Although near the end, I have a few notes about that. But this talk is mostly about bugs that show up in people that write applications for the node.js runtime. And so who's the audience? It's sort of the, my audience is sort of split into 3 pieces, hopefully. One is obviously if you're a node.js developer. Hopefully the content will be useful as to sort of what not to do and how to mitigate it or how to fix these things. The second part of my audience is security reviewers, right? If somebody says, hey, we have a node.js application and somebody needs to do a security review, I hope the content in the slides will be useful to tell you what to look for and where to look for it. And obviously the third part of my audience, sort of if you're just a curious security guy, or if you're a web app guy, or general security curiosity, then hopefully there will be something interesting in here. Right, so what is node.js, right? Essentially, node.js is a server-side JavaScript environment. And so what the node.js guys did is they took Google's V8 JavaScript engine, made it and it's single-threaded, and then they added on a bunch of APIs that made it really powerful from a server-side perspective. The whole thing is designed to be asynchronous. And so the APIs they added allow for things like creating and reading files, doing all sorts of crypto stuff, executing files, creating processes, forking off things, that type of stuff. And that's all done in C++. And on top of that, there's a large set of JavaScript runtime APIs that are built on top of that. And in a nutshell, that is kind of node.js. So why did I start looking at node.js? Well, first of all, I mean, node.js has become really, really popular over the last couple of years, right? There are like tons and tons of people writing node.js code. And so with that, obviously they'll make some security mistakes. Hopefully after this presentation, they'll be a little bit more informed and create fewer security bugs. And maybe, if we're lucky, fix the ones that are already there. And so this talk really came about when, I think a year or so ago, one of our business development people came to me and said, hey, we have these customers who want to do node.js reviews. Does anybody have any experience with doing security reviews for them? And so at the time we didn't, and so I started looking and sort of the collection of things I found and assembled sort of came into our first proposal for a pen test, as well as got poured into these slides. One of the first things I try to do is I try to find real-world node.js examples. And usually when I look for samples, the first thing I do is I go to sourceforge.net. And then after spending some time where I couldn't really find anything interesting on node.js, kind of realized, I had to check on GitHub instead of sourceforge.net, which is, I guess, this sort of mind paradigm shift where SourceForge is sort of, old school, whereas GitHub is newer. And so maybe it's a sign I'm getting old. So what does a simple node.js application look like? Well, basically, you basically say, require HTTP, require URL, and then you just create a server. And so what that does, it's one simple call. It creates a full HTTP for you. It provides for an asynchronous callback. And an asynchronous callback, you can handle requests, and you can send responses, right? And it's literally, not even 10 lines of code, right? You can see it right here on the right. Create server, and then you say, write response back, this, that. That's how easy it is to create like a hello world node.js application, right? It's literally that simple. Now, even with something that simple, there's a few things that would still require a fair amount of things to do, and so there's a number of frameworks, very commonly used frameworks, that are built on top of node.js. I'll jump into a few of them for a little bit, but they're not really the focus of this presentation, though. So one of them is Croc, and the other one's Express, and there are numerous other node.js frameworks. So that's sort of my intro, right? And so now we get into sort of the three sort of types of security bugs I've seen. And so I'll start off with what I call, between quotes, modern web app security bugs. And this is sort of the stuff that you see in most applications. It's not node.js specific, but I want to cover it because they do occur in node.js as well. And so I'll basically show what it looks like in node.js. I'm kind of assuming for the modern stuff that people know what these bugs look like. And so I'm assuming people know what cross-site scripting is. And so if you start looking at node.js applications, one of the things you will find is you will see cross-site scripting bugs. You'll see reflected, you'll see stored. Both of them can occur, and I see both of them happen. Right, node.js has no magic APIs to get rid of cross-site scripting bugs. They show up in node.js code as well. And so what does that look like? If you take the simple example that I showed earlier, and you basically go, oh, this is the response, and this is the response message, and you take data that comes from the request, and you don't HTML encode it. Sure enough, you get cross-site scripting bugs, right? No big surprise here. So yeah, if you're reviewing node.js applications, chances are you'll run into this, right? If you're writing node.js code, if you're a node.js developer, you should be aware of cross-site scripting bugs, and the idea is that you should escape the input that you're going to put in your output. Depending upon the data, it might be HTML, JavaScript, or URL, XML, JSON. They all need proper escaping, right? And so I have a little bit of code at the end that sort of shows how to do a simple HTML escape. As I said, it could be JavaScript or HTML or XML or JSON or a whole bunch of these things. And based upon which type it is, there's different types of encoding it, and between some it's very subtle, between others it's not. If you do all that yourself, it gets a little bit tedious, and it becomes easy to make a mistake. Turns out there are modules that can help you with this. So one's node validators, the other one's secure filters, and using those, sort of you no longer have to worry about the implementation of escaping, right? You just have to make sure escaping is done, but beyond that, escaping should all be good. Should there be a bug in there, it's no longer your problem. It's the library's problem, right? So that's about it for cross-site scripting. Another common bug that you see in web applications, obviously, is SQL injection bugs. And again, I'm assuming people know what SQL injection bugs are. They look exactly as they do elsewhere in Node.js. Now, they're not actually as common in Node.js because it seems that most of the Node.js approach seems to favor this NoSQL-like databases. So they don't show up as often. And the other thing is Node.js doesn't have native SQL support. So everything is done through modules. So if you combine those things, you don't see them often, but they do occur, and they're definitely possible in Node.js applications. So this is basically an example that I created where, this is clearly a trivial SQL injection bug. So they look the same in Node.js as they do elsewhere. one of the things is when I looked on GitHub, I couldn't really find much SQL usage, but I did find some like Yahoo query language usage, which is very SQL-like. And this comes from a real application where you have this node application that does a Yahoo query, and you say, what's the weather for the city? And then this has a Yahoo query language SQL-ish injection bug, basically. So yeah, again, the mitigation for SQL injection, this shouldn't come as any surprises, is parameterized queries or prepare statements, right? If you're a web app or a web service developer and you use SQL, these should be very, very familiar terms. And basically, the question there is to be consistent. Don't ever, always use parameterized queries, always use prepare statements. Don't ever deviate, because the moment you do, you're going to have a SQL injection bug, basically, right? Okay, so again, another one which I guess falls in the modern web app bugs is cross-site request forgery. Again, I'm going to assume the audience knows what this is. It's not language dependent, and it's really sort of a side effect of shoddy web app design. These occur, and because it's not language dependent, it's more of a design and an implementation issue. They do occur in node.js as well. The thing is that XRF is mostly the absence of code, and so it's hard to show an example in code. So node.js doesn't natively offer cross-site request forgery protection. I think that's a missed opportunity because node.js is new. They could have given you an API or a way to easily introduce this. They didn't. The good news is, though, that a lot of node.js frameworks do offer cross-site request forgery protection, right? One of them is Kraken, which is a popular node.js framework written by the guys at eBay. But if you must roll your own cross-site request forgery, right, the idea is basically that, and I'm assuming people notice that you generate a token that's cryptographically secure, and the idea is that you send the token to the client, and when the client does its post or whatever request, it gives you the cryptographic token, and then on the server side, you basically get to compare that token with the one you stored, and if they match, then you let the request go through, otherwise you fail the request, right? That's more or less how it works. It also sounds easier than it is. First of all, cryptographically secure. Getting cryptographically secure numbers is not always easy as it seems. The other thing is that when this cross-site request forgery model was perceived, it was sort of before the Web 2.0 model, where it was very simple. You had a simple HTML file which gave you a hidden form, and then you respond to that form, and it was a simple one-to-one transaction. With modern Web 2.0 apps, where you get all this JSON that interacts with each other, it's very the line gets very vague as to what exactly is a transaction, and do you actually have to use a token for every request that's going done, or is it okay to have a token per session, or those kinds of things? So because of those questions, it really is easier than it seems. Ideally, if you're a Node.js developer, the best thing to do is to basically use a framework such as Kraken, and that saves you a whole lot of hassle, right? The idea then is that because it's not your code, if things go wrong, you get to blame someone else, right? It's the library's fault. So another one in the category of what I call modern web app bugs, and again, this shouldn't be a big surprise to the audience, is HTTP response splitting. So I'm going to assume the audience knows what this is. And so Node.js is actually kind of clever when it comes to response splitting, right? It will not allow splitting of the header value. It will allow splitting of the header name. Now, it's really rare that a client gets to have control over the header, the name that server sends back, but I don't think it's unprecedented, right? And so I wrote this very simple proof of concept where basically you see the next line in the header name, and then if you test this, sure enough, there's HTTP response splitting in there. So it is possible, but only in the header name, and so that makes it quite rare, but not unprecedented. And so the question is there really a case for it? You can probably work around it. Now, if you must have a header name that has some control, where the client has some control, right? And you can't work around it, right? You, as a developer, you have some options, right? You can go for a whitelist and say, if it's not A to Z, we filter it out. Or you can say, if it's not A to Z, instead of filtering it out, we just fail the request. Or you can go for a blacklist and say, well, if I see N, then I'll filter it out. Or you can go for a blacklist and say, oh, if I see N, then drop the request or that type of stuff. So there are options there if you need to protect against response splitting of the header name. So that sort of covers the sort of modern web app stuff, the stuff that's known, the stuff that you see on pretty much any given web app review. Now we move into what I call classic web security bugs. This is sort of the nostalgia bugs of the 90s that you would see in these Perl scripts, and it turns out a lot of that stuff sort of rears its head again in node.js applications. The first one is sort of the elephant in the room, right? Because it's JavaScript, JavaScript has this eval call, and the eval call is totally supported in node.js. It's exactly as bad as it sounds. You take basically a string which may or may not contain user supply data, and you run it through eval, and eval basically sort of interprets it as JavaScript code and basically just runs it. Very clear case of code injection. One of the cases where historically this used to happen was, when you take JSON and you want to deserialize a JSON, you basically just go eval, and then it sort of stores it into a variable you can then use. So one of the cases where you see this in node.js is where there will be some kind of JavaScript library that they're reusing that somebody made years ago, which basically takes JSON data and puts it into an eval, right? Those things do occur. So here I have a very, very trivial example where you basically have an application that is a very simple calculator, and then you take a calculation request and you shove it through eval, and then eval gives you the result. That calculator definitely works. That calculator also gives you remote JavaScript code execution on the server, which is pretty bad. Yeah, as for the developer guidance into using eval, the simple answer is don't use eval. It's that easy, right? This is one of those bugs where you have no excuse. It's a terrible bug. I think eval should be put on a banned API list for server-side programming. There's just no real way to do it right. So the next that sort of flows into this is exec and spawn. So node.js offers these APIs called childprocess.exec, which is more or less the equivalent to using the system library call in C. Any user input in there is obviously really bad. You get remote command injection. Similar to that, there's childprocess.spawn, which is sort of the equivalent of exec. It forks off one process and runs the command. Again, there might be some problems there where if you're allowed to pass arguments to it, for example, an attacker may be able to do some kind of switch injection depending on what the application does. So one of the things is I went on GitHub and I looked for use of exec, and this is just one of many examples that I found of a real application that basically says, oh yeah, okay, you just uploaded this image, and then what we're going to do is we're going to run this through image magic, and we'll call exec, and we'll call this convert application with the image file name. And sure enough, if you create an image file name that's convoluted enough, this is where you get remote command injection. So the simple sort of developer guidance and mitigation here is basically don't call exec on a non-static string. You're basically asking for trouble, right? If you must pass untrusted data along to an application, use spawn or exec file. Even that is not foolproof. You have to be really careful. You have to make sure the application that you're passing that into is built, knows there's a trust boundary there, and doesn't implicitly trust the arguments. You have to make sure you don't have switch injection. You have to make sure that the application wouldn't easily fall to things like buffer overflows and the like. So you want to make sure that the application you're calling is aware of its trust boundary, and you want to make sure that there's no switch injection, right? Ideally, you don't want to call spawn exec file, but if you do, be very careful. Another sort of what I call classic web bugs, and it's not specific to web bugs, but it shows up quite often in web applications. It's sort of the standard directory traversal, right? This can happen when you open a file requested by the user, and you basically go like dot dot slash dot dot slash dot dot slash, right? And again, so I went on GitHub and I looked for read file, and sure enough, when you do, I found this one application that basically goes, oh yeah, we'll just take the raw file name and then I'll just hand you back the file. And so I ran the application, and I simply did get dot dot slash dot slash dot slash dot slash etc password, and sure enough, it gives me my password file back. So that's a very, very trivial example of directory traversal issues in node.js applications. And so yeah, as I mentioned, that's an example of real code that I found on GitHub. This is something we've known this has been a problem for 20 years easily. It again resurfaced in node.js. As a simple developer guidance, it's sort of the don't do that, right? When somebody hands you a file name or a file path, don't just implicitly trust it. You must verify that it's a real file, that you don't access directories and that type of stuff. And it turns out that doing proper file name validation is harder than it looks. And so ideally, don't take raw file names, right? So that's sort of the what I call classic security bugs, sort of the stuff you saw in the 90s in Perl scripts. So now we sort of get to the miscellaneous security bug stuff, and I think this is where some interesting things show up. I want to start off talking about random numbers. So earlier I talked about cross-site request forgery and the need of cryptographically strong numbers. And so node.js has a specific API for this. They have crypto.random bytes, and if you look at the documentation, it says this generates cryptographically strong pseudo-random data. It also has a similar and related API called crypto.pseudo-random bytes, and this says, the documentation says, generates non-cryptographically strong pseudo-random data. The data returned will be unique if it is sufficiently long, but is not necessarily unpredictable. For this reason, the output of this function should never be used when unpredictability is important, such as generation of encryption keys, which is exactly the kind of token that you want to prevent cross-site request forgery, right? It says in that case, use the otherwise identical crypto.random bytes. So if you must use cryptographically strong random numbers in node.js, by the documentation, you must use crypto.random bytes, right? And so that would apply to cross-site request forgery tokens. And so I spoke of Kraken before, and if you look at the way Kraken generates its tokens, is they call crypto.pseudo-random bytes, so they're doing exactly what documentation told them not to do for secure tokens. And so yeah, Kraken's one of this. And so I started looking at, okay, how does node.js actually generate tokens? Like how bad is it? And if you start looking at the implementation, it turns out it's a very thin layer around OpenSSL crypto APIs, right? So they'll have this function called random byte worker, and then there's basically a boolean that says, is it pseudorandom or is it not pseudorandom? And if it's pseudorandom, it calls the OpenSSL API random underscore pseudo bytes, and if it's not, it calls the OpenSSL random underscore bytes API. And then if you go look at the OpenSSL documentation for this stuff, you notice that almost one for one, the documentation of node.js's APIs and the OpenSSL APIs are almost identical. They make the same guarantees, they make the same promises, right? So if you look at the OpenSSL API for random underscore bytes, they'll say, it puts X amount of cryptographically strong pseudo-random bytes into a buffer. An error occurs if the RNG hasn't been seeded with enough randomness to ensure a predictable byte sequence. And then there's pseudo byte, which says puts a pseudo-random number of bytes into a buffer generated by a random pseudo bytes. It will be unique if they are of sufficient length, but not necessarily unpredictable. This can be used for non-cryptographic purposes, but usually not for key generation, right? So those sentences in the documentation match almost word for word with what node.js says. So it's really clear that they're just very simple wrappers around it, right? And so I started thinking about this is that the real problem with crypto.random bytes is that it should block and wait for entropy, and if it doesn't, but right now it doesn't, it just fails. And so that doesn't fit well with the node.js asynchronous model, right? where you don't want to have that kind of model. And so the question is, how do we fix this? Right, there's no real easy answer to how to get strong cryptographically secure bytes out of a random number generator in real time or near real time, right? And one of the things I was thinking is, well, I guess you could pre-allocate piles of random data, and maybe node.js should expose pseudo APIs. Anyway, I didn't really have a good answer on that one. So my buddy Kaminsky had some solutions in his DEF CON talk from last year, and I put a link in there, and so you can look there, and maybe that gives you some better answers. I don't really have a good answer on how to mitigate the random number usage. So the next thing I sort of noticed was that the console.log is an API that basically sends data that logs to a log file, and you sort of have this. It doesn't really do any character filtering, so if it takes data that comes from an untrusted user, there's a possibility of like raw log injection. In and on itself, it's not necessarily a bad idea. It's not a bug on its own, but if you combine it with these things where administrators tend to use tools to view log files, and the idea is that they assume it's trusted content. And if it's not filtered, there are certain attacks that are potentially possible, right? In the past, we've seen these attacks called, terminal escape codes. So if I can inject some like weird terminal escape codes into like the console.log file, and then the admin views it, depending on which terminal they're using, it may allow reading or writing files or even executing commands depending on what the terminal does. That's one. And the other is that you might be able to inject unprintable characters that fool the administrator. So if the administrator just looks at it, it might look as if you've rewritten some log entries. So an admin might be able to get a false sense of security, or might think something has happened that didn't happen, or might not be able to see something that did happen. There's a whole bunch of like weird things you can do there. And this is just a very simple example that I made, where basically you say create server, and you take a piece of data that comes from the HTTP request, and you do console.log, and then you put it to the console, and then if an admin views that, there's potential for either terminal escape codes or overriding or making it appear as if something isn't in the log file, right? As for developer guidance, I mean, an easy way to fix this is basically to have a small wraparound console.log where you basically escape unprintable characters, in user-defined input before passing to console.log, and you filter out things like escape and unprintable characters, and that should take care of it. Okay, this is sort of the last bit of my presentation. This is sort of the stuff I looked at that I think is really interesting. And so basically the idea behind node.js is that it's supposed to be really, really fast, right? And so normal JavaScript has data structures, strings, arrays, and so forth, that come with a managed language overhead, right? Things like bound checks and that type of stuff. So node.js introduces this thing called JavaScript buffer classes. And they're implemented in C++, and they're a very, very thin layer around new and delete. So there's very little stuff that gets done beyond that. Essentially, this gives the power of raw memory to node.js application. And this stuff is used everywhere. If you look at a bunch of the node.js applications, you'll see that a lot of them will take these buffers as input. And there's three ways to create a buffer, right? One where you just say, create buffer, here's a length. One is where you give it a JavaScript API and potential encoding, and one is where you give it a JavaScript string and you give it an encoding. The length one is basically a very simple malloc-like wrapper, right? You basically say, okay, give me a buffer of 100 bytes, and it hands you back a buffer, which is basically backed by a raw pointer that points to 100 bytes of memory. It is uninitialized, so it literally gets handed to new, and new gives you a pointer, and you basically get to read and write that data without it ever being initialized. Now, if you come from a C background, it's not that big of a deal, but if you, which most JavaScript Node.js developers would be, if you're a developer that is used to managed programming languages, this could be a problem, right? It's done for perf reasons, but I think it has enormous like Heartbleed-like potential, where I don't think Node.js developers really know like what the risk is or that these things are even uninitialized. So you may end up with like a buffer where you say, oh, give me 1,000 bytes, and you only, let's say, write 100 to it, then you send it back to the client, but you give it a full 1,000 bytes. All of a sudden, you've leaked 900 bytes of uninitialized data. So I think that there's enormous risk and potential there for Heartbleed-like bugs. And when I read about this on some Node.js documentation, I couldn't believe it, and so I tried it, and it's really that simple. You say buffer 50, and you like it's just it's all initialized data, and then you do it again. It's all initialized data, right? So I think that's really bad. The other thing is that these buffers have APIs to read from them and write to them. So that you can either use the bracket operator or you can use the read and write APIs, right? And with the read and write APIs, you can specify an offset. So that allows you to read and initialize data, but does it also allow you to read and write out of bound, right? That's one of the things I investigated. The bracket operator is safe. It does bound checks. Now, once you start looking at the write APIs, it says the following, right? As it writes a value to the buffers and so forth, it says set no assert to true to skip validation of value and offset, right? This means that value may be too large for a specific function, and offset may be beyond the end of a buffer, leading to values being silently dropped, right? Now, that document is being silently dropped, so that means you shouldn't have an out-of-bound read or write. The read documentation says the following, right? It says no assert should be set true, skip validation for offset. This means offset may be beyond the buffer, defaults to false. So that one doesn't document whether it would be dropped or it would actually go through, right? So the documentation is at very least inconsistent. But so both say that what assert does, but then one says it will drop, the other one says it doesn't. But it gets worse, right? So if you actually start testing this, the reality is stranger than what documentation says. In reality, all read and write APIs for integers will silently ignore out of bound if no assert set. Once you get to the float APIs and the double APIs, out of bound read and writes just happen, right? And so you can have out of bound reads, you can have writes, you can have buffer overflows, and so potentially remote code execution, right? I suspect that was an implementation oversight. I tested this on version 0.10.31, and sure enough, if you have a simple test case here, you create a buffer, you say, read 300 bytes out of bound, it gives you a blob of data. If you say write out of bound, if you go far enough out of bound, it'll say segmentation fault crash. So my conclusion or developer guidance when using buffers is basically, watch out when doing raw buffer allocations. As a developer, you have to be aware the data is uninitialized, right? And sending uninitialized data memory over network can obviously have disastrous consequences. Like, that's exactly what Heartbleed was, right? And then the other one was sort of the out-of-bound read and write through the float APIs are, I think, likely implementation oversight. I think that level of API misuse where you have to send the no assert flag, I think is rare, and so the potential for buffer overflows, I think, is slim. But the fact that the APIs allow for it, I think is weird, and I think it's not implementation oversight, though. Yeah, so that's basically that was basically sort of my run through of these types of bugs I've seen in Node.js code. There's really no magic here, right? Node.js battles with the same problems as other web languages and frameworks have. Additionally, sometimes it feels a little bit, if you look for security bugs, feels a little bit like 90s style Perl CGI bugs, right? I think when I was looking at this, the most interesting thing I saw was sort of this buffer thing, which is really Node.js specific, and it has a lot of potential for information leak bugs. Also, I think this is just the tip of the iceberg. I think there's lots and lots of interesting security research that we can still see in Node.js applications. Okay, that was pretty much it. Craig, we should open it up to questions if anybody has any.
Yeah, if we have any questions, unfortunately I can't unmute you, just the system that we work with, but there is a little questions bar at the bottom that you can type your question into, and we can then read those out. I have one here at the moment. It says, in my humble opinion, it's still my problem, even though the fault is in the library. It's still my application that's vulnerable.
Yeah, so I'd imagine that's one of these things where I said use a library for things like cross-site request forgery. Yeah, I think that I agree with that opinion. I think that's the way it is. Like if it still runs within your runtime, it should be your problem. A lot of developers don't see it that way. If they use a library and it's one of these things where you get to point a finger, right? So it depends of your interpretation. I like this opinion. It's kind of my opinion too. Most developers don't see it that way, right? If it's not, if the bug is in the library they use, then it's the library's problem and not their problem, even though your website is still vulnerable, right? So I think that was a good point. And the other one was, do you find any kind of common authentication problems in any of the frameworks? So I didn't look too much for authentication in the frameworks. Most of them, from what I've seen so far, have relied on things such as OAuth. So it's sort of the reliance on the protocol. There may be implementation issues there. I haven't looked too deep. So I haven't seen. I really haven't seen any common authentication problems because I haven't spent much time looking for them. There may be, there may not be. I don't know. Hope that answers the question. Okay. If there are no more questions, then Craig, I guess we can wrap it up. Oh yeah. Okay.
Yeah, yeah, it looks like that's it. No more questions. So yes, thank you everyone. Thank you, Ilja, for hosting this today, and yes, thank you everyone for joining us. What we will do is we're going to wrap this recording up, get it loaded up to our YouTube page, and we'll also get it posted to our website, and that should hopefully all go live by tomorrow. So feel free to come along, and if you want to revisit the presentation, you're more than welcome to. So thank you everyone for joining us.
Awesome.